bituminous macadam. This is the most important pavement layer as it provides characteristics such as friction, smoothness, noise control, and shoving resistance. In addition, it prevents the entrance of excessive quantities of surface water into the underlying layers. The thickness of Dbm layer varies as per the project site location and requirement. It is laid in 1 or 2 layers depending on its design thickness. Prior to laying of Dbm layer, the WMM top layer is swept clean free from dust and foreign matter by using mechanical broom and air compressor. After this, the prime coat is applied on the WMM bed. This work consists of the application of a single coat of low viscosity liquid bituminous material over an existing porous and absorbent pavement surface. The main objective of the prime coat is to plug the capillary voids of the porous surface and to bond the loose mineral particles on the existing surface using a binder of low viscosity which can penetrate into the void. The bituminous primer is sprayed uniformly using a mechanical sprayer at the specified rate of 0.6 to 0.9 kilogram per square meter. To measure the rate of spray, an empty tray is weighted and placed on the surface on which the prime coat is to be applied. The differential weight of the tray before and after the application of the prime coat indicates the rate of spray of the emulsion. The prime surface is allowed to cure for at least 24 hours, during which period no traffic is allowed. After 24 hours, tack coat is applied on the existing pavement surface, which is relatively impervious like an existing bituminous surface. The purpose of application of tack coat is to prepare the surface for laying of Dbm over WMM surface treated with primer. Tack coat, also known as bond coat, is a light application of asphalt emulsion between hot mix asphalt layers designed to create a strong adhesive bond without slippage between the new pavement and the existing pavement. The application of tack coat is at the specified rate of 0.2 to 0.25 kilogram per square meter. To measure the rate of spray, a tray is placed on the surface on which the tack coat is to be applied. The differential weight of the tray before and after the application of tack coat indicates the rate of spray of the emulsion. The construction engineer needs to check the nozzles of the self-propelled emulsion sprayer. They all have to be clean and angled in the same direction to get the proper cover. After the application of tack coat, the process of laying of Dbm is initiated. Dbm is prepared in the hot mix plant. Different sizes of aggregates are blended in suitable proportion with bitumen. These are then loaded in the tipper and then transported to the site. The Dbm sample is also checked for the laboratory test to measure mix grading of aggregate, binder content and aggregate grading, plasticity index, cleanliness, aggregate impact value or Los Angeles abrasion value, flakiness and elongation indices, soundness, water absorption, stripping value, water sensitivity of mix, sand equivalent value, polished stone value, and Marshall test data. Before laying of Dbm, string line are fixed on both sides of the surface with the help of steel pegs at 5 or 10 meters interval, 5 meters for curved roads and 10 meters for straight roads. The level is checked by the surveyor as per the requirement of the Dbm level. The Dbm is spread with the help of a sensor paver. A paver has basically two parts, a tractor and a screed. The tractor provides power and includes a hopper where the mix is deposited. The screed function is to smoothen and partially compact the mix. All requisite inspections are carried out before laying of the mix. The paver is then set as per levels and time. The sensor is located in a small box with an arm extended below it. The arm rests on the string line and detects bump in the surface. The top of the string line guides the sensor of the paver and adjusts the screed to achieve the desired level. Laying of bituminous mixtures shall not be carried out when the air temperature at the surface on which it is to be laid is below 10 degrees unless specifically approved by the engineer. The tipper should stop about half a meter ahead of the paver so that the paver can move forward to contact the tipper tires with its roll. The construction engineer should see that the contact is smooth and even. Two push rollers mounted on the front of the hopper push the tippers along the bed. The tipper loads the mix into the hopper of the paver. Two conveyors inside the hopper transport the mix to the paver. The auger distributes the mixture evenly in front of the screen. The construction engineer should visually inspect the mix. If some aberration is noticed, the plant inspector should be intimated. The temperature of the mix at the time of laying is in the range of 120 degrees centigrade to 160 degrees centigrade. A high temperature can damage the binder in the mix, but if the mix is too cold, rollers won't be able to compact the mix adequately. The screed partially compacts and smoothens the mix by its vibration and damping action. The contractor should have enough tippers to maintain constant supply to the paver. In that way, the paver moves continuously at the same speed. In addition, constant supply of material aids the mix to be placed and compacted at a constant temperature, which helps to provide a good mat. All deficiencies in the surface after laying are made good by the attendant behind the paver before initial rolling is commenced. The surveyor continuously checks the levels to ensure proper grade and slope with the help of reference pegs. After laying are made good by the attendant behind the paver. Compaction of bituminous material commences as soon as possible after laying. Compaction is substantially completed before the temperature falls below the minimum rolling temperature. Compaction of the material is achieved by using 80 to 100 kN smooth yield static and vibratory tandem rollers. Each pass of the roll uniformly overlaps not less than 1/3 of the track made in the preceding pass. The construction engineer should check that all necessary precautions are taken to prevent dropping of oil, grease, petrol or any other foreign matter on the pavement either when the rollers are operating or standing. Moreover, before the commencement of the rolling operation, the construction engineer should also check the drums of the rollers. If they are not smooth, there is just no hope for a smooth pavement. To prevent the mixture from adhering to the wheels, drums have to be also kept moist. Thus, it is made sure that all the sprinkle nozzles are in working condition. The initial or breakdown rolling is done with 8 to 10 tons dead weight smooth wheel roller. The intermediate rolling is done with 8 to 10 ton dead weight or vibratory roller and with a pneumatic tired roller of about 12 to 15 tons weight having 7 to 9 wheels with a tire pressure of at least 5.6 kilograms per square centimeter. The finish rolling is done with 6 to 8 tons smooth wheel tandem roller. Rolling shall continue until all roller marks have been removed from the surface. The Dbm will be tested immediately after finishing for density test as performed on the extracted core. The desired field density of the extracted core is 98% of the laboratory Marshall test. Similarly, the Dbm top layer is also laid on the Dbm first layer. Initially, tack coat is applied on previous layer. The tippers load bituminous mix into the hopper of the paver. Regardless of the type of tipper used, a major concern is fuel and oil leakage, which can contaminate the mix. So, the construction engineer should spot check all the trucks before paving begins and time to time thereof to see there are no leaks. Then, the paver spreads the mixture uniformly across the bed. After that, the rollers compact the layer according to the desired level. It is also subjected to density test. The desired field density of the extracted core is 98% of the laboratory marginal test.